Hello everybody. Thanks for watching this video. In this video we are going to see how to analyze a thread data. So here we go. Thread data. So before we analyze, we have to understand the definitions of deadlock, thread contention. Thread contention is a status in which one thread is waiting for a lock held by another thread to be lifted. Different threads frequently access shared resources. So deadlock, a special type of thread contention in which two or more threads are waiting for other threads to complete their tasks in order to complete their own tasks. So then we should understand the thread status. The thread status is like this: runnable status, new status, terminated status, blocked or waiting or time waiting status. So those are the various thread statuses. So the runnable status, the thread is occupying the CPU and processing a task. It may be in waiting status due to OS resource distribution. So that is runnable. So overall what it is doing is occupying CPU and processing a task. Overall it is in waiting status. Then what is waiting status? The thread is in waiting status by using a wait, join or park method. So this is runnable status is in waiting status. The waiting is in join or park method, but this is not really in waiting status. Block, the thread is waiting for different thread to release its lock in order to get them on run. So one thread is depending on another thread for its lock to get released. That is called, it is blocked thread. Time waiting thread, the thread is waiting by using a sleep, wait, join or park method. The difference from waiting is the maximum waiting time specified by the parameter. So then the waiting can be relieved by the time as well as action changes. That comes under time waiting. So now these are the various status of threads. Now let's see. So what are the different Java threads? Daemon threads and non-daemon threads. So daemon threads stop working when there are no other non-daemon threads. So even if you do not create any threads, Java automatically will create these daemon threads. So a thread running static void main string logs method is created as a non-daemon thread, and when this thread stops working, all other daemon threads will stop. So a non-daemon thread is an independent thread, whereas a daemon thread stops working when other non-daemon thread ends. So that is how these two threads are working. So now for analyzing a thread, you can download this tool which is having thread analyzer and thread information from the thread dump file. Right. So before we understand much in detail, so we have to understand the status, the priority, the thread ID. What is this thread ID? The thread ID could be like this: either pool 1 thread 1. This is thread name. This is thread name. So a thread name. A thread name, when you are using Java lang, developer is using Java.lang thread class, it will be thread minus number. When developer is using Java, it will component of thread for thread. It will be pool number, thread number. Priority represents the priority of the threads. Thread ID represents the unique ID for the threads, including represents the unique ID for threads. Thread status represents the status of the threads, which we already discussed just now. So thread ID represents the unique ID of the thread. So thread calls status, we don't need to worry much about that. So when a thread is unable to obtain a log file, it is block status. Deadlock status. When thread A needs to obtain a thread-based lock to continue manage task, and when thread B needs to obtain thread A's log to continue its task, then it's deadlock status. In that case, you can see that deadlock test1 thread has this log, and deadlock is trying to obtain 60, and test2 has 60 log, and it is trying to obtain the 48 log. Similarly, you can say 78 log, and 78 is using with the deadlock 3 1, and it is waiting for deadlock 1 thread. So this is how a typical deadlock scenario goes. It could be 2 deadlock threads, or it could be 3, whatever. So no one can release, and they all are in deadlock situation. So what is runnable? So when a thread appears to be normal, since its status keeps showing runnable. However, when you align the thread chronologically, you can see that socket read thread is waiting infinitely to read the socket. So the runnable status also is showing nothing. So the thread, when waiting, the thread is maintaining wait status in the thread down. So IO wait thread keeps waiting to receive messages from linked blockade blocking queue. If there continues to be no message for linked blocking queue, then the thread status will not be changed. So that is what is waiting status. So there are two common scenarios. When the CPU usage is abnormally high, what could be the reason you think? The reason is due to blocker status. And similarly, when performance is abnormally slow, it is due to blocker status. Similarly, when the CPU usage is abnormally high, right? When the CPU usage is abnormally high, the thread is in wait status. If you solve that problem, if you analyze it, the thread is in runnable status. So if the performance is abnormally slow, it could be due to the blocker thread. So that is example, one of example. So after that, so overall the conclusion is you can acquire the amount of time that the threads waited or blocked by using the so there are two possibilities, waited or blocked. So whenever you are analyzing your thread dump using a Java code using a tool, you should focus on more on waited or blocker threads. If you have CPU starvations, you should focus on waited. If you have performance issues, slowness, block, you have to focus on block. Thanks for watching the video. That's the conclusion.